Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In episode 135, we explore the network design strategies used to maintain connectivity when links, providers, or routing paths fail. Uptime is not a luxury, it's a requirement. Whether supporting cloud applications, remote access, or critical communication services, networks must be resilient. And that resilience depends on path diversity. For Network Plus candidates, this topic appears frequently in high availability and WAN connectivity questions, particularly those that test your ability to prevent outages through redundancy. This episode focuses on WAN and Internet redundancy, how to build networks that survive outages, ISP failures, and localized disruptions. Path diversity ensures that when one route goes down, another can take its place without interrupting service. We'll explore concepts like single-homed versus multi-homed connections, load balancing across ISPs, failover mechanisms, and physical path separation. These techniques help you design infrastructure that performs well under pressure and keeps traffic flowing even during partial failures. For the exam, understanding both the logical and physical aspects of redundancy is key. Path diversity means having multiple routes to the same destination. These paths can be physical, such as using two different fiber providers, or logical, such as different routing paths through the same carrier. By introducing alternate routes, organizations eliminate reliance on a single connection. If one path fails, another takes over, preventing downtime. On the exam, you may be asked to define path diversity and explain how it supports fault tolerance in WAN and Internet design. A single home network connects to only one ISP or one WAN uplink. While simple, it creates a major single point of failure. Multi-home networks, on the other hand, connect to multiple ISPs or uplinks, creating path diversity. This approach allows for better load sharing, higher availability, and improved failover response. Many enterprises use multi-homing to maintain constant internet access even during carrier outages. On the exam, be prepared to identify the limitations of single homing and the advantages of multi-homed network topologies. Load balancing across internet connections distributes traffic between multiple links to optimize bandwidth usage and reduce congestion. This can be configured in round-robin fashion, weighted by link speed, or based on session persistence. Load balancing also enhances failover by ensuring that links are actively used and monitored. If one fails, traffic can shift immediately to the remaining path. The exam may include scenarios where load balancing ensures continued access during peak usage or unexpected link failure. Failover mechanisms are essential for WAN redundancy. These systems monitor link health or ping checks, routing metrics or application layer probes, and automatically reroute traffic when a failure is detected. Some failover setups use predefined priorities or administrative distances to determine which path should be primary and which is backup. The faster the detection and rerouting, the less impact on users. The exam may ask you to evaluate different failover designs or identify which metric allows fallback to a secondary link. WAN aggregation devices are purpose-built appliances or routers that combine multiple WAN circuits, often from different carriers, into a single logical connection. These devices manage bandwidth, enable failover, enforce quality of service policies, and provide advanced routing features. At the network edge, they're responsible for connecting the internal network to the outside world. WAN aggregation is a common part of multi-homing strategies. On the exam, expect questions about how aggregation devices support redundancy and performance. Border Gateway Protocol, or BGP, is the routing protocol used to manage connections between multiple ISPs. BGP supports policy-based routing, allowing administrators to control both outbound and inbound traffic. With BGP, you can set routing preferences, balance load across providers, and ensure consistent internet presence even if one provider fails. BGP also enables automatic rerouting around internet-level disruption. The exam may present multi-homing scenarios where BGP is the correct choice for routing between ISPs. Physical path separation enhances redundancy by ensuring that different WAN or internet circuits do not share the same conduit or route into the building. If all cables are buried in the same trench or run up the same pole, a single cut can take down all services. Proper redundancy involves having physically diverse entry points, cable runs, and termination locations. On the exam, be ready to assess redundancy based on physical layout and to recognize the risks of shared infrastructure. Routing metrics and administrative distances play a major role in determining which path is preferred during normal operation and which one acts as a backup. By assigning lower administrative distances or routing costs to primary routes, networks can automatically switch to higher-cost secondary paths during failures. This ensures that failover happens cleanly and predictably. On the exam, questions may ask you to interpret routing tables and explain how distance values enable path prioritization. DNS redundancy also contributes to overall network availability. Organizations should maintain multiple DNS servers, ideally located in different geographic regions and hosted on different networks. Hosting internal DNS alongside external providers like Google or Cloudflare helps ensure resolution continues even if one DNS service becomes unreachable. The exam may test your understanding of DNS failover and how redundant name resolution supports internet access and application uptime. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Maintaining internet redundancy is essential for continuous access to cloud services, especially in organizations that rely on software as a service platforms and APIs for daily operations. Without redundant links, a single ISP failure can block access to critical applications, impact remote work, or disrupt communication platforms. Solutions like dual ISP configurations, SD-WAN, and multipath routing allow traffic to reroute automatically to the most reliable provider. For hybrid and remote workforces, this ensures uninterrupted access to tools even when one connection fails. On the exam, expect to match redundancy designs with scenarios involving cloud availability and service continuity. VPN failover is another aspect of maintaining secure connectivity during outages. Remote access VPNs should be pre-configured with secondary tunnel endpoints so users can reconnect automatically if the primary path is lost. Many VPN appliances support active monitoring of tunnel health and can fail over to a backup connection without user intervention. This protects secure access to internal resources even when an ISP or site link goes down. On the exam, you may encounter questions about VPN continuity and how failover supports secure operations. Out-of-band management adds another layer of redundancy by providing a dedicated management path separate from the production network. Often, this path uses a cellular modem or separate broadband connection that allows administrators to access equipment when the primary network is unavailable. This capability is especially useful during major outages or misconfigurations. With out-of-band access, administrators can reboot devices, apply patches, or reroute traffic without depending on the same systems they are trying to repair. The exam may test your understanding of how out-of-band management ensures recovery and supports administrative access during failure. Monitoring tools are essential for tracking redundancy status and detecting issues before they escalate. These tools continuously check the health of both primary and backup links and generate alerts when failovers occur. Logs help track which path was used, how often failover happens, and how quickly recovery occurred. This visibility is necessary for tuning failover thresholds and improving reliability over time. For the exam, you may be asked how monitoring contributes to redundancy verification and proactive incident response. Documenting redundant internet paths is a key part of operational readiness. Network diagrams should show each carrier, the circuits used, routing devices, and failover logic. BGP configurations, administrative distances, and ISP contact information should also be included. This documentation helps teams troubleshoot faster, plan upgrades, and engage vendors effectively during outages. The exam may ask which documentation elements support redundancy planning, or how diagrams reveal single points of failure. Security must also be considered when implementing path redundancy. All failover paths should be encrypted if they carry sensitive data, especially if alternate routes traverse public networks. Firewall policies must remain consistent across paths to avoid introducing holes during a switchover. Monitoring is needed to detect asymmetric routing when outbound and inbound traffic follow different paths, which can lead to session drops or exposure. On the exam, you'll be expected to identify security risks in redundant path setups and recommend ways to harden them. Redundancy comes with challenges. Implementing multiple connections, firewalls, routers, and tunnels increases cost, requires more complex configuration, and demands ongoing testing. Redundant paths must be validated regularly. Failover that doesn't work when needed is as dangerous as having no backup at all. Misconfigured redundancy may create routing loops, asymmetric flows, or performance degradation. On the exam, be prepared to answer questions about troubleshooting redundant path designs and the trade-offs involved in cost, complexity, and maintenance. To summarize, path redundancy is not about overbuilding, it's about designing for resilience. It keeps users connected during outages, supports applications that demand always-on availability, and protects access to internet-based and internal services. Whether using load balancing, dual WANs, BGP, or SD-WAN, the goal is the same: ensure business continuity. On the Network Plus exam, you'll need to recognize when and how to apply these strategies to meet uptime objectives and mitigate risk. To conclude episode 135, diverse paths and internet redundancy are foundational to a reliable network. They eliminate single points of failure, support remote work, protect cloud access, and keep business moving even when disruptions strike. From routing metrics to out-of-band management, the techniques you've learned in this episode form the backbone of availability and high-performance design for the exam. And your career, knowing how to build and maintain redundancy, is essential. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.